Hi, this is Kiran. Dear students, how are you? Hope so, preparing well. Now, in this module 5, we are going to discuss a very important theorem as well as a formula. Equation of a circle passing through two given points. What are those points? x1, y1 and x2, y2, which subtends an angle theta on its circumference. See, on a circle, we are considering any 2 points. That 2 points makes an angle theta on the circumference on either of the sides. Let us observe the diagram now. Yes. Have you observed that? There is a circle. On the circle, there is a first point, there is a second point, which are subtending some angle theta. Hope you can expect the circle equation now. But please remember here, the common mistake done by the student is he will be feeling that there will be only one circle. It's not true. There will be two circles possible. Let us check it out now. Now, there is a point x1, y1. There is a point x2, y2. Passing through it, there is a circle. Those 2 points are subtending some angle theta. Obviously, you will be getting a doubt that where is the second circle? Let us check it again. Yes. Which means that what I mean to say, in this condition, there are two circles possible. Now, to find the equation of the circle, let us have some notation. Consider the first point A as x1, y1, B as x2, y2. Consider any general point x, y, denoted by P. Now, let P, x, y be any point on the circle, and theta is the given angle subtended by the points A and B. What is the locus condition given here? Have you observed that? The condition given here is the angle between PA and PB. Why do we take only P and PB? Because P is a general point. Anyway, A and B are given points. The angle between them is theta. That itself is the locus condition to find the equation. In our previous straight lines chapter, already we know that if theta is the angle between any two straight lines with the slopes m1 and m2, then tan theta is equals to mod of m1 minus m2 by 1 plus m1 m2. That we know already. Here, slope of AP is m1. Y minus y1 by x minus x1. What is that? Slope of AP. How? What is the slope of a straight line equation? Passing through 2 points x1, y1, x2, y2, y2 minus y1 by x2 minus x1. That everyone knows. Applying that formula, slope of AP is m1 is equals to y minus y1 by x minus x1. Slope of BP is m2, y minus y2 by x minus x2. Substituting these values in the above formula and eliminating modulus. Plus or minus tan theta is equals to, with a small simple calculation, you will be getting that terms. Simple calculation it is, you can follow it on your own. But while doing the calculation, don't open the brackets, it is a hint. Plus or minus tan theta is equals to y minus y1 into x minus x2 minus x minus x1 into y minus y2 by x minus x1 into x minus x2 plus y minus y1 into y minus y2. Please remember that as a formula. It's a very important formula for all your competitive examinations. For what it is the formula? There is a circle. On it, 2 points will be given with a condition that 2 points subtend some angle theta. Then the equation is plus or minus tan theta is equals to y minus y1 into x minus x2 minus x minus x1 into y minus y2 by x minus x1 into x minus x2 plus y minus y1 into y minus y2. In the formula, if you observe plus or minus, if you consider plus, there will be one circle equation. If you consider minus, there will be another circle equation. Now, equation of a circle passing through x1 y1 and x2 y2, and the points are extremities of a diameter is, see, if the two given points are the extremities of a diameter, already we know that if the points are extremities of a diameter, any diameter in a semicircle subtends a right angle. Once again, in the basic geometry, already we know that in any circle, any diameter in any semicircle subtends a right angle. That is there in your basic geometry. Now, what do you mean by right angle? 90 degrees. So in place of tan theta, if you replace 90 degrees, you will be getting indefinite form. When do you get indefinite form? Provided the denominator is 0. Of course, that itself is the equation of the circle. Equation of a circle passing through x1 y1 and x2 y2, where the 2 points are extremities of a diameter, is in the above formula. You can consider that denominator x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. Please remember that also. But before going to further discussion, the above formula is very important. But here there is a notion for the student. In our intermediate syllabus, the equation of a circle whose extremities of any diameter are the points A, x1, y1, B, x2, y2 is, there is some other method. Of course, it is a very simple method, but in the previous explanation, it is only a particular case. Let us consider that also now. There is a diameter taken, the extremities. x1 y1 and x2 y2. Consider a general point P x comma y. Are you able to see now that diameter is making some angle 90 degrees? Let Pxy be any general point on the circle. We know that angle in a semicircle is right angle. Everyone knows that in the earlier classes. In straight lines chapter, the perpendicularity condition is m1 m2. What is this m1 m2? Product of the slopes. What is that? Product of the slopes. In straight lines chapter, the perpendicularity condition is product of the slopes is equals to -1. What are the slopes we need? Slope of PA and slope of PB. Of course, they are perpendicular. Here, m1 is equals to slope of PA, that is y minus y1 by x minus x1. m2 is equals to y minus y2 by x minus x2. Now, substituting in the perpendicularity condition. What is the perpendicularity condition here? m1, m2 is equals to -1. After simplification, we get the equation as x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. Of course, that is the circle equation. Have you seen it anywhere just now? Yes. In the previous task, it is a case. Hope you understood well. Prepare well.